Good afternoon, children.
Good afternoon.
Good afternoon.
Good afternoon, ma'am.
Hi, children. Good afternoon.
Good afternoon, ma'am.
Good afternoon. Yeah, to begin with, we'll recall the two theorems which we saw in the last class. So the first one is the tangent at any point of the circle is perpendicular to the radius through the point of contact. Through the point of contact. So you need to memorize the statement, understand and memorize the statement. So the tangent at any point of the circle, tangent means where to draw the tangent at any point of the circle. The tangent at any point of the circle is perpendicular to the radius which is drawn through the point of contact. So circle, any point on the circle, tangent okay, so tangent at P. So this is any point of the, this is any point on the circle. P is any point on the circle. And this is the tangent. L is a tangent through the point of contact P. Now the tangent at any point of the circle is perpendicular. This tangent is perpendicular to the radius. Radius, which radius? The radius which is drawn through the point of contact. P is the point of contact. And OP or PO is the radius drawn through the point of contact. So this radius OP and this tangent L are perpendicular to each other. This is one. And the other theorem we learned was the tangents. So to recall from here, given a point inside the circle, no tangent can be drawn. No tangent can be drawn to a circle given a point lying inside the circle. Given a point on the circle, exactly one tangent can be drawn. Many lines can be drawn passing through this given point. Many lines can be drawn passing through the given point. But of those infinitely many lines, only one line can act as a tangent to the circle. Given a point outside the circle, exactly two tangents can be drawn. Exactly two tangents can be drawn to the circle from a given point outside the circle. So given a point P outside the circle, exactly two tangents, PT and PT dash, exactly two tangents, PT and PT dash, can be drawn to the circle. So the second theorem we learned was based on this one. So when we draw, so we know that we have two tangents. Exactly two tangents can be drawn from a point lying outside the circle. Now this theorem is the two tangents will be equal in length. The second theorem, that is the theorem after this, the second theorem in NCERT is that the tangents drawn, the lengths of the tangents drawn from an external point of the circle are equal. That is PT is equal to PT dash. So how do we prove that? We join point of contact to the center, radius OT and radius OT dash. Join OT and OT dash, and also OP, that is the line segment joining the center of the circle and the external point P. Line segment OP connects the center of the circle and the external point P. So OP is the line segment joining the center and the external point P. OT OT radius, OT dash radius, PT and PT dash are the tangents from the external point P. We need to prove that PT is equal to PT dash. So we take up these two triangles, OTP and OT-P. The triangles OTP and OT-P. 90 degrees, because by this theorem, radius perpendicular to tangent. I normally write it in short like this. You will not find it in books like this. I normally write that theorem like this: radius perpendicular to tangent or tangent perpendicular to radius. Anyways, you can write. So when I write this, I mean this theorem. For this theorem, in short, I normally write like this. You'll always see this. I normally don't write like this: radius perpendicular to tangent. So when I write this, I'm talking about this theorem. Okay, so in these two triangles, in triangle OTP and OT-P, angle 1 is equal to angle 2. Angle 1 is equal to angle 2 because radius perpendicular to tangent. Then OP is a common hypotenuse. OP is equal to OP, common hypotenuse. R, H, and S now. OT is equal to OT dash. OT is equal to OT dash. See, these are parts of the triangle OTP, and these are parts of the triangle OT-P. We are not writing something. Angle 1 of this triangle is equal to angle 2 of this triangle. Side OP of this triangle is equal to side OP of this triangle. Side OT of this triangle is equal to side OT dash of this triangle, because radius of the same circle. So RHS congruence rule, the two triangles are congruent. CPCT, corresponding parts of congruent triangles are congruent. So PT is equal to PT dash. Now this is all you will find in NCERT, but we can learn two more theorems based on this. So we'll see that now. So from here, today's session begins. So far we recalled what we saw in the last class. The two theorems we saw in the last class. Circle, external point P, tangents PT and P from the same external point P, center O, OT, radius, OQ, radius. OP, line segment joining the center and the external point. Now, you can prove that this angle is equal to this angle. Again, congruency. So that is angle 1 is equal to angle 2. And also angle 3 is equal to angle 4. Angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Congruency. We proved already the triangles are congruent. RHS rule, the triangles are congruent to each other. So CPCT, you'll have this angle. This angle is equal to this angle, and also this angle is equal to this angle. When you prove that these two triangles are congruent, to say that tangents from an external point of the circle are equal, that is PT is equal to PQ. RHS congruence rule, the triangles are congruent. So therefore PT is equal to PQ. Therefore PT is equal to PQ, CPCT. You can also continue to say all this. Angle 1 is equal to angle 2, CPCT, because the triangles are congruent. Angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Same thing, same congruency, you can continue to give these results. But there the theorem was, to show that tangents from an external point of the circle are equal. So we stopped there. PT is equal to PQ because that's what we had to prove according to the statement. So we start with that. PT is equal to PQ, CPCT. We proved that the tangents from the external point of the circle are equal. So you can also say angle 1 is equal to angle 2 and angle 3 is equal to angle 4. So what is this angle 1 is equal to angle 2? CPCT. But what is that? So angle 1 is the angle subtended by the tangent P. So see, what am I trying to say? I can stop here. Angle 1 is equal to angle 2 CPCT. But how do you express that? How do you express that? What is angle 1? Angle 1 is the angle subtended by the tangent PT at the center. Angle 2 is the angle subtended by PQ at the center. Now, PT is equal to PQ because tangents from an external point to the circle are equal. Now, angle 1 is the angle subtended by PT at the center. Angle 2 is the angle subtended by PQ at the center. So we say that, no, this here I was just telling you how to express angle 1 and angle 2. What is angle 1? It is the angle subtended by tangent PT at the center. What is angle 2? It's the angle subtended by PQ at the center. Now we say that equal tangents subtend equal angles at the center, equal angles at the center. So that is trying to say that angle 1 is equal to angle 2. Equal tangents, when tangents are equal, equal tangents will subtend equal angles at the center. Since PT is equal to PQ, the equal tangents, they'll make equal angles at the center. Angle 1 is the angle subtended by, see, if you want to understand how do you know that that's the angle subtended, I'll tell you, see here, circle. See, let me start like, okay. Okay, here we have only the tangents. Okay, now how do we show or represent the angle subtended by the tangent, PT at the center? How do you show or how do you draw or how do you represent the angle subtended by the tangent PT at the center? For that, first mark off the ends of the tangent. P and T are the ends of the tangent. Now, where do you want it to subtend the angle? At the center. So mark off the 3 points. P and T is P and T are the endpoints of the tangent. P and T are the endpoints of the tangent, and we are trying to represent the angle subtended by the tangent PT at the center. So what you have to do is join the endpoints of the tangent to the center. Join the endpoints of the tangent to the center. T is an endpoint of the tangent. So tangent is a line, children, but I told you this is a tangent segment. Okay, so join T to the center O and join the other endpoint P to the center O. To the center O. Now this is the angle. This is the angle subtended by the tangent PT at the center. Now same for tangent PQ. Q and P are the endpoints. P and Q are the endpoints. So join P to the center, Q to the center. So this is the angle subtended by tangent PQ at the center. See, now if you have a line AB, and a point C here, if you join AC and BC, you can say that this is the angle subtended by the line segment AB at C. Supposing you have a line segment AB and a point outside C. If you join A to C and B to C, if you join A to C and B to C, this angle formed is the angle subtended, SUB, this is okay, subtended by. So this is the angle subtended by the line segment AB at the point C. So that is got by joining the endpoints of the line segment to that point C. So equal tangents subtend equal angles at the center. Angle 1 is equal to angle 2. And for angle 3 is equal to angle 4. What do we say for angle 3 is equal to angle 4? Equal tangents are equally inclined to the line segment joining the center and the external point. For 3 is equal to 4, equal tangents are equally inclined to the line segment joining the center and the external point. So that is angle 3 is equal to angle 4. Equal tangents are equally inclined to the line segment joining the center and the external point, which means angle 3 is equal to angle 4. So what is that? Circle, line segment joining the center and the external point, line segment joining the center and the external point. Now, this is one tangent, okay? So this is a tangent from the point P. This is the inclination. This is the inclination of the tangent. This is the tangent. PT is a tangent. This is the inclination of the tangent with the line. What is OP? It is the line segment joining the center and the external point. How do you express the line segment OP? The line segment OP is the line segment joining the center of the circle and the external point P. Now the tangent is PT. This is the inclination of the tangent with this line segment OP. It's inclined at this angle. Like, see here, now if there's a mountain, and this is the road or the ground, okay? So this is the inclination. This is the inclination. The foot of the mountain. This one is inclined to the ground at this angle, whatever. Yeah. So this is the inclination. And similarly, for the other tangent, PQ is the other tangent. PQ is other tangent. So this is the tangent. This is the baseline kind of. See, for an angle, we already for an angle, we always need a baseline, no? So like in 5th or 6th standard, when we first use the protractor to measure angles, so the teacher would have told you to first take a baseline. First take a baseline. To measure or to draw an angle, you need a baseline. Without a baseline, you cannot represent an angle. So if you have to measure 60 degrees using the protractor, you need to first take a baseline. And then you keep your protractor here and measure 60 degrees. Measure and you draw. This is 60. So this is 60 degrees with respect to this baseline. Angle is always represent. See, you can identify angles only with respect to something. Something should already be there. With respect to that, you can measure the angle. Simply, if like if the this is the mountain, this the steep of the mountain, you cannot measure the angle with respect to what? So with respect to the ground, this is the angle. So angles are always measured with respect to a baseline. So in that sense, this is the inclination. This is the inclination of the tangents with respect to this baseline. This is the inclination of the tangents with respect to this baseline. And that baseline is the line segment joining the center and the external point. So we say that equal tangents are equally inclined. Why equally inclined? Because angle 3 is equal to angle 4. So they're equally inclined to the line segment joining the center and the external point. This is the line, this is the baseline which connects the center and the external point. So how do you express angle 3 is equal to angle 4? Equal tangents are equally inclined to the line segment joining the center and the external point. That is, if PT is equal to PQ, then angle 3 is equal to angle 4. PT is equal to PQ, not if, meaning, since, okay, let me say, since PT is equal to PQ, angle 3 is equal to angle 4. Since PT is equal to PQ, angle 1 is equal to angle 2. Because PT is equal to PQ, angle 1 is equal to angle 2 and angle 3 is equal to angle 4. So this is about, till here is about the introduction of 10th standard. Now we need to recall a few things from circles of 9th standard in order to continue with the exercises. Now, I'm not going to, we'll try to recall in less time, children. So I'll just give you a question and ask you the answer. A, B, O, C. If this angle is 70 degrees, okay, 50 degrees. If this is 50 degrees, find X. Let's take some situations to recall the theorems, children. I'm not stating the theorem and telling you what it is. I'll just give you some situations. So by answering these situations, we'll recall the theorems from 9th standard. Yeah, what is the answer to this?
100, no.
X is equal to 100 degrees. Very good. X is equal to 100 degrees. It's double. It's double. Yeah, X is equal to
90, ma'am.
Okay. All of you. Prajit answered the first one. Second one also only he's answering. All of you think, recall.
Is it 45?
Okay, yeah. We'll learn the correct answer in some time. Others participate, children. Okay, so Prajit, you were first incorrect and then correct. Yes, it's 45 degrees. X is equal to 45 degrees.
Yes,
Very
ma'am.
good. Very good.
ACB.
1 second. If angle AOB is equal to 70 degrees, then X is equal to Y is
X
equal
is
to
35 degrees, ma'am. X is 35
X is?
degrees. 35, ma'am.
X is 35 degrees and Y
35, ma'am.
45, ma'am.
35 degrees. Yes, very good. Yeah, X is equal to 1 second. 70, that is. X is equal to?
And 110.
How is it possible, Prajit?
I thought straight lines. 180.
Straight line at one point, the sum will be 180, not at two different points. Okay, let me just talk on that. So see, straight line, correct. Straight line, like if this is 70, this can be 110. This is 110. If this is straight line, if this is 70, this cannot be 110. Not at two different points. The sum
Yes.
is 180 at the same point. At the same point, the sum is 180, not at two different points.
Ma'am, is it 200?
Wow. Who is that? Please. You're making fun of me.
Ma'am, Rakshita.
Rakshita, darling, come on. You're making fun of me. How is it 200,
Sorry,
darling? The
sorry.
triangle. And
I was
see the inclination. How can it be 200? 200 is a reflex angle. You know, 200 is like, this is 200 degrees. This is 200 degrees. Yes, children. Yeah.
Is it 55?
No, it is not 55.
Is it 30?
Is it 30? Who's that? Madhumita?
Shashank, ma'am.
Shashank. Okay. So tell me, how did
Ma'am,
you get
is it
30? Yes, somebody else said something. Yes, Shashank, 30, then
Ma'am, this is Rakshita. Is it 20?
20. Okay, Rakshita, 20. Okay. Rakshita, from 200, you removed 10, is it?
No, ma'am, I got confused last.
Okay. So Rakshita, from all the way from 200, she's come down to 20. Fine. And Shashank says 30. Now, who of the two should I say is right? So Rakshita is right. Well tried, Shashank, but Rakshita is right. It's 20 degrees because AOB is the diameter. And we know that the angle in a semicircle is a right angle. The angle in a semicircle is a right angle. So which makes angle ACB 90 degrees. So 90 plus 70 is 160. 180 minus 160 is 20. This also we have studied last year. Angle in a semicircle is a right angle. What is that angle in a semicircle is a right angle? The angle subtended by the diameter is a right angle. That's the meaning. Now that you understood what is subtending, the angle subtended by the diameter at any point in the circle, the angle subtended by the diameter at any point of the circle is a right angle is the meaning. So now let's take any point on the circle. See. Now, how do you represent the angle subtended by the diameter? Well, we have to mark off the end points of the diameter and join that to that point C. So join A to C and B to C. This is the angle subtended by the diameter AB at the point C, which is a right angle, which will always be a right angle. Angle in a semicircle is a right angle because this is semicircle. No, this is semicircle. This is semicircle. So angle in a semicircle is a right angle, or the angle subtended by the diameter at any point on the circle. It's not inside the circle, children. See, this is not a right angle. On the circle is a right angle. See, AB is the diameter. Oh, this one is not 90 degrees. This one we don't know. Or outside the circle. This one also we don't know. The point should be on the circle, children. The C, see here C lies inside the circle. Here C lies outside the circle. These are not 90 degrees. If you take this point C on the circle, then it is 90 degrees. So here you can see AB is a diameter. I did not tell you it's a diameter, but you can see it passes through O. If it passes through O, O always represents the center of the circle. It need not be given that O is the center of the circle. If it is some other letter, if I marked it with P, then I should tell you that P is the center of the circle. If I mark the center as P, then I must tell you that P is the center of the circle. If I don't tell you it is the center of the circle, you cannot assume it to be the center of the circle. So if supposing it's not given that P is the center of the circle, then you cannot assume APB to be the diameter. But it was marked O. So you need not, have a second thought if it is a center or not. O always is used to represent the center of the circle. So that means AOB is the diameter. And C is a point on the circumference of the circle, join A to C, B to C. So this angle is a right angle. Angle ACB is equal to 90 degrees. So since ACB is 90 degrees, then by using the angle sum property in a triangle, X is equal to 20 degrees. Is that clear, children?
Yes, ma'am.
Okay. And, so Rakshita, how did you figure it out?
Ma'am, the way you told only, ma'am.
Okay, fine. All right, children. So, yeah, that's all it is. And then one more thing is this. I want you to first find X and then find Y and then find Z. I want you to first find X.
Ma'am, X is 120 degrees.
X is 120
Very good. Yeah, very good, Madhumita. Yes. What's the property then?
The opposite sides of a cyclic quadrilateral are supplementary, ma'am.
Very good. Yes. So ABCD is a, let me mark ABCD. ABCD is a cyclic quadrilateral. A, B, C, D is a cyclic quadrilateral because you can see that the vertices A, B, C, and D lie on the circumference of the circle. All the points, that is all the vertices, the four vertices, A, B, see, A, B, C, D is a quadrilateral. A, B, C, D is a quadrilateral. And since the four vertices of the quadrilateral lie on the circumference of the circle, ABCD is a cyclic quadrilateral. And as Madhumita said, in a cyclic quadrilateral, opposite angles are supplementary. X plus 60 is equal to 180. So X is equal to 120 degrees. X is equal to 120 degrees. Now, how do we find Y? What is Y and Z?
Y is 60 degrees, ma'am.
Y is 60 degrees. Danya, yes, Danya, please justify that.
Adjacent angles of cyclic quadrilateral are supplementary, ma'am.
So how much did you say? 60, yeah?
Yes, ma'am.
No, I'm just thinking if adjacent angles of a cyclic quadrilateral are supplementary, there's no property like that. Adjacent angles of a cyclic quadrilateral need not be supplementary. They may be, but they need not be. Yes, children.
Ma'am, Z is 60 degrees, ma'am. Because X and Z are co-interior angles.
No, but I wasn't asking Z. I was asking Y.
Y is also 60 degrees, ma'am. No, ma'am, Y is 120 degrees.
Y is 120. No, suddenly when Danya said adjacent angles of cyclic quadrilateral are supplementary, for a second it made me think like, oh my God, is there a property like this? Yeah. Then I just, comforted myself and said, no, there is no property like that. Yeah. So sometimes students make us think, So yeah, so there is no property like that. Adjacent angles of a cyclic quadrilateral may be supplementary. Not that they cannot be, but that's not a property because it's not always true. So here I've marked parallel lines. See here. So co-interior angles are supplementary. Co-interior angles are supplementary. That's how you get. So because this is 60, Y is 120. And now opposite angles of a cyclic quadrilateral are supplementary. So Z is equal to 60 degrees. Okay, there's one more. So all this will be used in solving numericals and circles this year. All these ideas plus a few more ideas will be added using all this. So when you're given a numerical sum, all these ideas must come to your mind. All meaning you must be using all these properties or theorems or results to crack that one numerical sum. One second, I'm just thinking. Okay. No, I think I have to give a direct one. 1 second. It's pretty direct, children. Yeah.
His answer 100.
Property?
The answer is 100.
Exterior angle is equal to the
To the?
opposite.
Yes, Sashank. Yes, Sashank. Yes, Prajit, you can complete.
The opposite interior angle is equals to exterior angle.
No, you cannot say from there. You must say exterior angle only first. Exterior angle is equal to its interior opposite angle. Okay. Sashank, what is the property?
Ma'am, linear pair.
Linear pair, huh?
Opposite angle. Opposite angle of
Okay,
cyclic
okay. Linear
quadrilateral.
pair. Very good, very good. Yes, I understand. Yeah. Then one more. There was one more student with the answer. Yes.
Ma'am, is it 100, ma'am?
Yeah, it is 100. Tanishka, reason?
Ma'am, A is 100, ma'am. It's a cyclic quadrilateral. Opposite sides we will get 80, ma'am. And
Okay.
if we complete the angle, we will get 100, ma'am.
Very good, Tanishka. Very good. So when Tanishka and Sashank worked it with the same idea. First, both of you found the opposite angle. Opposite angles are supplementary, so we get 80 here, and then linear pair. So this 100. But I must say Prajit hit it straight because that's a property of a cyclic. All of you are right. So that's a property of a cyclic quadrilateral. Exterior angle is equal to its interior opposite angle. This exterior angle x is equal to its interior opposite angle 100. So x is equal to 100 degrees. X is equal to 100 degrees. Exterior angle, this is the exterior angle. This is the interior angle. So interior opposite angle is this one. This is the exterior angle. And for this exterior angle, this is the interior angle. For this exterior angle, this is the interior angle. Interior opposite angle, this one. So this angle is equal to this angle as a result. This angle will be equal to this angle. So if say this side is produced, this is the exterior angle. This is the exterior angle. For this exterior angle, this is the interior angle. This one is the interior angle. This is the interior opposite angle. This angle is equal to this exterior angle is the result. Or you can do it this way also. From 100, you can find 80 opposite angle is supplementary and then linear pair. So x is equal to 100. Both are fine. So all these results we must remember, children. So coming from the beginning, the angle subtended by an arc at the center is double the angle subtended by the same arc at any point on the remaining part of the circle. 9th standard theorem. But you know, I think in some schools they omitted this theorem. I'm not sure because of this portions being deleted. Some schools have done it, some schools have not done it. So this is how it is. You can see this figure and see the positions. See the positions x and 50. X is at the center, O, and C is on the circumference. C is a point on the circumference. O is the center of the circle. If at the circumference the angle is 50, at the center it will be double 100. If the center is 100, the circumference is 50. At the center, the angle is always more. The angle is more at the center. So you just look at this figure, register this figure in your mind. O is a point at the center, or O is the center of the circle. C is a point on the circumference of the circle. The angle at the center is always double. So that's why we got x is 100. Similarly, see here. In the second figure, C is a point on the circumference. A is a point, A is the center of the circle. Center only is double. So center is 90. That means x should be half of it, 45. Center is double. So on the circumference, it will be half of it, 45. So here again, if the center is 70 degrees, third one, if the center is 70, on the circumference, x will be 35. X and y both are on the circumference. They'll be equal. On the circumference, all the angles will be equal. So if x is 35, y also will be 35. I'm just helping you recall. I'm not explaining in detail actually. So don't think this is the way it is to be explained. No. I'm just helping you recall. So if you have your 9th standard maths textbook, you can just go through this part. So at the center here, at the in the third one, center is given 70. So circumference is half of it, so 35. Y is also a point on the circumference. So both 35. X is 35, Y is also 35. And in the fourth one, we recall that angle in a semicircle is a right angle. So this angle ACB is 90 degrees. And then by using the angle sum property, we got x is 20 in the fourth one. In question number 5, in a cyclic quadrilateral, opposite angles are supplementary. So this is 60. So x is equal to 120. And then co-interior angles are supplementary. This parallel lines we've been seeing since 8th standard. Parallel line transversal, co-interior angles are supplementary. So if this is 60, x plus y is equal to 180. What is this? 60 plus y is equal to 180. Co-interior angles are supplementary. 60 plus y is equal to 180. So y is 120. If y is 120, z will be 60 because again opposite angles are supplementary. If y is 120, then z will be 120 plus 60 is 180. So z is 60. Then here, exterior angle of a cyclic quadrilateral is equal to its interior opposite angle. $30 degrees, okay? This is 30 degrees, children. Yeah, find x. If angle ABO is 30 degrees, then x is equal to. Yeah, please think about it and answer me. Tanishka, 60, yeah?
Shashank.
Oh, Sashank, how much? 60,
60
yeah?
degrees, ma'am. Yes, ma'am.
You're right. Please explain, Sashank.
Ma'am, triangle AOB is an isosceles triangle. Therefore,
Very
angle
good.
OBA
Yeah,
is equal
that's what I
to
wanted children to
OB.
realize. Sashank, thank you. Thank you. 1 minute, Sashank. Yes, that's what I wanted children to realize. AOB is an isosceles triangle. That is the realization you must, when you see this figure, you must realize that. AOB is an isosceles triangle. Because OA is equal to OB. Why is OA equal to OB? Because radius of the same circle. Very good, Sashank. Yeah, please continue.
Ma'am, so that if we add both angle OAB and OBA, we'll get 60 degrees. And the ASP is that all the angles of property, we can say that angle AOB is equal to 120 degree. And angle X is half of the angle AOB, therefore angle X is equal to 60 degrees.
Very good. Very good, Sashank. I'm happy that you were able to, like we all know AOB is isosceles, but we should realize at that particular time, right? When you're solving, when you're cracking the sum, you should realize after finishing the exam paper, when you realize, oh shit, that was an isosceles triangle, there's no point. So it's not that nobody knows this is an isosceles triangle. All of us know it, but we didn't realize it. AOB is an isosceles triangle because OA is equal to OB, radius of the same circle. So if this is 30, this is also 30. This is also 30. Then angle sum property AOB will be equal to 120. Half of 120 is 60. So x is 60 degrees. So far we've recalled all the properties from 9th standard from this chapter circles. We've recalled theorems or results from the chapter circles of 9th standard. Now we have one more to go of 10 standard. Once we are done with that, then we can start solving the questions in the exercises and then outside your NCRT book. Just give me a minute, children. I'll just come back. Please give me a minute. Tanishka, please disable your mic. Yeah, thank you, children. Another 5 minutes, we'll wind up today's session. Yes, children, I'm back. Yeah. So last but not the least is the alternate segment theorem. Now we don't have to learn the proof for this theorem. You just have to remember the result. Okay, so like the conditions which must be given in order to use the result of this theorem. Okay, so consider this tangent at the point P to the circle, and PQ is a chord. PQ is a chord. So in this alternate segment theorem, you have to look out for a chord, and we know that a chord is a line segment. So it has two endpoints on the circumference of the circle. So PQ is a chord. Its endpoints are P and Q. Now through this endpoint P, we have a tangent to the circle. The tangent can be also from the other endpoint Q. Okay, so you'll have to look out for a chord. Its endpoints, so here P and Q. Is there a tangent through Q? No. Is there a tangent through P? Yes. Now you need to locate a point on the remaining part of the circle. Okay, so say remaining part of the circle, which means like the chord is contained by this arc. This minor arc contains this chord. We'll also talk with respect to the major arc. Let me tell you one by one. Now consider a point R on the circumference of the major arc. Consider a point R on the circumference of the major arc. Now, this is the angle subtended by the chord PQ at the point R. So for that, we'll have to join PR and QR. If you join the end points of the chord to a particular point, that is the angle subtended by the chord at that point R. So PQ is the chord and PRQ is the angle subtended by the chord PQ at the point R on the circumference of the major arc. Okay, so now this angle is subtended by the chord at the point R on the major arc. All right, now look at this, children. What is this? This is the angle between the chord and the tangent. This is the angle between the chord and the tangent. This is the angle between the chord and the tangent. The result says that this angle X is equal to Y. X is equal to Y. X is the angle between the chord and the tangent. and angle and y is the angle subtended by the chord at a point R on the circumference of the major arc. Now, what is this so vague? X is equal to y. How? Now, with respect to the chord PQ, with respect to the chord PQ, this is the minor segment and this is the major segment. This is the major segment with respect to the chord PQ. With respect to the chord PQ, this is the major segment. Major segment. This one is the minor segment. Minor segment. Now, this angle, you know, this angle, you see, can you see it's a part of the angle goes through the minor segment here. The angle, it goes to the minor segment here. This angle between the chord and the tangent, it passes through the minor segment. So this angle is the angle between the, we say that this angle is the angle between the chord and the segment in the minor, sorry, this angle is the angle between the chord and the tangent in the minor segment. While this angle is subtended by the chord in the major segment. That is why alternate segment theorem. One in the minor segment, the one angle is in the minor segment, the other angle is in the major segment. Alternate segment theorem. An angle should be subtended by the chord in one segment. And the angle between the chord and the tangent should be in the other segment. An angle should be subtended by the chord in one segment. And the angle between the tangent and the chord should be in the other segment. That's why alternate segment theorem. One in the minor segment, the other in the major segment. Alternate segment theorem. So I'll show you again. Circle, requirements, circle, chord. One endpoint of the chord. Tangent through that point. Tangent through that point. This is the angle between the chord and the tangent in the minor segment. Minor segment. So take a point R in the major segment. So take a point R in the major segment and represent the angle subtended by the chord in the major segment. This is the angle subtended by the chord PQ at the point R in the major segment. This angle is equal to this angle. Is it understood, children?
Yes, ma'am.
Okay. So not many yes. Are we there in the meeting or you all left?
Yes, ma'am, I
Class use
understood.
emoji. Yeah, class use emoji. Raise your hand. Madhu, Madhumita, Shri Krishmi, Sashank, Prajit, Tanishka, Florentina, Rakshita, Arjun. Dilipan is there. Okay. Now here we have the angle subtended by the chord in the major segment and the angle between the chord and the tangent in the minor segment. Let's take the other case. Let's take the other case where the angle between the chord and the tangent is in the major segment, this angle. The angle between the chord and the tangent is in the major segment. This is the chord. This is a tangent. And this is the angle between the chord and the tangent in the major segment. Then the chord must subtend an angle in the minor segment. So take a point R on the circumference of the minor arc or the minor segment. This is the minor segment. Join. I told you. That's why I told you how to identify the angle subtended by a line segment. So PQ is a line segment And this is the angle subtended by the line segment or the chord PQ at the point R, this angle. So this angle is equal to this angle. So here the angle subtended by the chord is in the minor segment. And the angle between the chord and the tangent is in the major segment. This angle A is equal to this angle B, alternate segment theorem. So there are two things, angle subtended by the chord in a segment, angle between the chord and the tangent in the alternate segment. That is the other segment, alternate. These are the two angles. These are the two angles. The angle subtended by the chord in a segment and the angle between that same chord and the tangent in the alternate segment. These two angles are equal. These two angles are equal. So supposing this is the tangent, sorry, this is the chord. Supposing this is the chord AB. Okay, chord AB. And supposing we have a tangent, oh, sorry. Okay, supposing we have a tangent like this passing through A. Okay, this is the tangent passing through. So chord AB, endpoints A and B. So through the endpoint A, we have a tangent T. Now, this is the angle between the chord and the tangent in the, this is the minor segment. Clearly, it's the minor segment, okay? So this is the angle between the chord and the tangent of the minor segment. So take a point anywhere on the circumference of the major segment, anywhere. You can take a point here also. Take a point C. Join the ends of the chord. Join the ends of the chord to that point C. So this is the other angle. This is the other angle. So this is the angle subtended by the chord in the major segment. And this is the angle between the chord and the tangent of the minor segment. These two angles are equal. These two angles are equal. And for the same figure, if you're talking about the angle between the chord and the tangent here, if you're talking about the angle between the chord and the tangent here, this is the major segment. Then you should take a point in the minor segment and join the ends of the chord to that point. So these two angles will be equal. This angle is equal to this angle. Am I clear, children?
Yes, ma'am.
All right.
Yes,
So,
ma'am.
very nice.
Yes, ma'am.
Very good, children. Very good. All right, children. So this is about the theorems which you need to know. Very important. This chapter circles is very simple and very important. And it's very scoring also because, if you visit all type of sums possible here, you will not have any surprises in the exam. It's very easy to score marks in this chapter. So we are done with the introduction part to the chapter circles. We have taken the introduction of all the concepts of 10th standard, plus we recalled all those which you need from circles from 9th standard. So I think next session, we are ready to, start off with the exercises in NCERT. So all right, children. So that's it for today's session. Thank you so much. You may leave the call. If you have any questions, you can stay back. Otherwise, you can leave the call, children. Thank you.
Thank you, ma'am.
Thank you, children.
Thank you.
Thank
Thank
you.
you, ma'am.
Yeah, thank you, children.